Hi guys, so for this video I picked out a 6-mark question for ideal gas equations. Pretty difficult question honestly, so yeah, let's break it down. It's given you that the circumference of a ball needs to be between this and this value, and actually it is already between those values, so that's fine. It's told you the pressure in the bowl is required to be this and this much above the atmospheric pressure, and it's also told you the atmospheric pressure, that is, sorry. So if you add 0.6 times 10 to the 5 onto this, you get 1.6 times 10 to the 5. And if you add 1.1 times 10 to the 5 onto the atmospheric pressure, we get 2.1 times 10 to the power of 5. That means that we're probably going to have to calculate the pressure in this question. And if it falls within this range, then it's met the requirement that it needs to meet. So let's find the pressure somehow. It's told you that when it's inflated, the temperature is 17 degrees. Now, one thing with ideal gases, when you're dealing with them in equations, you have to convert temperature into Kelvin. Actually, the number of Kelvin is the number of degrees plus 273. So straight off the bat, let's do that. 17 plus 273 is equal to 290 Kelvin. And that's the value of temperature that we're going to use in our equation later on. It's also told you the circumference is 690 millimeters. That's probably going to be useful in some way too. Deduce if the ball satisfies the law of football about pressure. Like we mentioned, we're going to find out the pressure and see if it falls between this range. It's also given you the molar mass and the mass of the ball as well. Let's break it down. So ideal gas equations, there's two that you can use. There's PV equals nRT, where N stands for the number of moles, or there's PV equals capital N, K, and capital T. Now here, I think it makes sense to use this first one because it's giving you molar mass and mass, so you can use that to find the number of moles. Let's break this down and rearrange for pressure first. Dividing both sides by volume, we get pressure is equal to the number of moles multiplied by the molar gas constant multiplied by the temperature in Kelvin, all divided by the volume. Now, the number of moles is equal to the mass divided by the molar mass. Pretty difficult to remember, but how can you remember it? Well, if you look at the units, if we divide the number of grams by the unit for molar mass, which is grams per mole, dividing by fractions means multiplying by the reciprocal, so it's the same as multiplying by the number of moles over grams, and these two can cancel out, leaving you with just moles. So that's why it gives you the number of moles. So let's do that. We can replace N now with the mass of 11.4. By the way, we don't have to convert into kilograms because it'll cancel out with this grams, so we can leave them both in grams, over 29. That will give you the number of moles. You multiply onto that the molar gas constant, which is a value of 8.31. That is in your equation sheet, by the way, for all examples. The temperature is 290 Kelvin, and we divide all of that by the volume of the shape. Now, because it is a ball, it's a spherical surface, and the volume of a sphere is equal to 4/3 pi r cubed. Has it given us any information that will point towards the radius of the ball? Yes, actually it has. It's told you the circumference is 690 millimeters. Sorry, I just wrote over it, but yeah, it's just there. So you multiply by, well, let's think about it. How can we go from the circumference to the radius? Circumference is equal to pi times diameter, or 2 pi r, because the diameter is 2 times the radius, meaning the radius is just the circumference divided by 2 pi. So we can take the value of the circumference given to us, 690, multiply that by 10 to the minus 3 to turn into meters, and divide all of that by 2 pi. This will give us the radius, and then we can cube all of this. Once you've done that in your calculator, I did it beforehand, and it will get you a value of 170769. In order to compare it to our range that we have, let's convert it to standard form. So that's 1.7 times 10 to the power of 5 pascals, which it does fall within this range. So this inflated ball does satisfy the football law about pressure. Pretty difficult question there, and I went through it quite quickly, so yeah, you can just rewind if you'd like, but I thought I'd go through this. Thanks for watching. Have a nice rest of your day.